Okay, thank you so much. My name is Yismaw Ayelign from Debre Tabor University, Ethiopia. So my lecture today is on efficiency and productivity analysis of manufacturing firms. Of course, my focus was initially on the firms, but today I will compare the macro level productivity between Ethiopia and Indonesia too, over different time periods. So I have my presentation has the following outline: efficiency and productivity, motivation to deal with, measurement approaches, macro level total factor productivity, and of course labor productivity, a comparison, and micro level efficiency and productivity, taking the Ethiopian manufacturing firms as a case. So when we come to deal with the motivation to deal with total technical efficiency and total factor productivity, higher level of productivity and efficiency is the goal that all economists strive these days, because its growth has directly linked with improvements in well-being of society, as it is confirmed by different scholars. For instance, Krugman confirmed that more than 50% of the variation in living standard levels across nations is explained by the variation in their multi-factor productivity or total factor productivity you can consider. So if total factor productivity has more than 50% explanatory power to the income differences across nations, then it should be a critical policy and academic as well as scientific issue, research issue. So long-run economic growth will be realized only if there is growth in total factor productivity, therefore. Of course, short-run economic growth can be achieved by different capital deepening and other means, but when we come to the long run, we have to deal with total factor productivity. So it is an issue from policy, from academics, and from scientific study point of view. As a result, we have been motivated to deal with total factor productivity and efficiency. Measurement approaches, there are measurement approaches, alternative approaches to both technical efficiency and total factor productivity. But first of all, both are estimated, both technical efficiency and total factor productivity are estimated from the production function, whether it is the goods production function or service production function. So we have to come to the production function in order to estimate technical efficiency and total factor productivity estimation. The estimation of production function has evolved over time as developed alternative methods that address the potential endogeneity issue. There is no one and same estimation technique for the production function, because alternatives try to address one or more of the endogeneity issues that production function estimation will face. Therefore, among these alternatives, the scholars have to focus on the main ones, because each one of have their own limitations and, of course, strengths. For estimation of technical efficiency, as it is evolved from just a two-component composite error term, the stochastic approach from estimation of two composite error terms to four, nowadays the four-component error term is applied. Initially, in 1977, two groups of scholars have developed the stochastic frontier approach using the usual econometric error component and the efficiency error component. But nowadays, efficiency itself has been grouped into persistent efficiency and transient or time variant inefficiency or efficiency, heterogeneity, and that of the usual econometric stochastic error component. So these much developments from 1977 to 2015, at least 2015, for productivity, which can be measured in terms of partial productivity, input factor productivity, say labor productivity, output per worker, or per unit of labor. You know, labor is measured differently as full-time employment equivalent, or it may be measured by the number of hours worked, or it may be measured by the payments, the compensation for the work, and alternatives. Among these, the proxy for the labor service, one is expected to take one which is more, better approximately a proxy measure, a good measure. Land productivity, output per hectare, for example. These are the partial parts. Otherwise, it may be measured as total factor productivity, which can be measured in either index numbers or frontier approaches. The index of output over the index of inputs may provide, using the index approach, may provide total factor productivity, or there are alternatives, the frontier approaches. Of course, the frontier approach in turn can be a stochastic frontier approach, or it can be data envelopment approach. The stochastic frontier approach uses the econometric approach. It considers the total deviation is not just inefficiency, but part of the deviation from the total, the potential or the frontier, is due to exogenous factors, shocks, which are beyond the control of the unit, the economic unit. So data envelopment approach, on the other hand, uses mathematical programming, and it is more of deterministic. The stochastic approach is stochastic. It uses stochastic error component, but the data envelopment approach uses mathematical programming at deterministic. Deterministic means all the deviations from the potential are due to inefficiency instead of part of it as a stochastic component or random time component. Of course, productivity can be measured in levels or growth rates. So differently, one can see. So we can deal with details of data envelopment approach and stochastic frontier approach. But basically, the data envelopment approach has these advantages, the following advantages. The first one is it does not require the assumption about, as far as we are concerned about production function, if we deal with stochastic frontier approach, there should be a specification of technology. But here in data envelopment analysis, there is no need, it does not require the assumption of employed technology in the production. So there is no need functional form. Whichever functional form, whether it is Cobb-Douglas, or whether it is Translog, whatever, or whether it is SACE, it doesn't matter. The functional form is not required here. The second advantage is there is no need for initial statement of whether the firm decision is guided by output or input orientation. As far as we are dealing with production function in stochastic frontier, we have to select whether we apply output-oriented or input-oriented. But here, in case of data envelopment analysis, we are not expected to choose either input or output orientation. We are free to do that. The third one is arising from the fact that it does not need the functional form. DA is free model specification of error. One of the endogeneity sources in case of stochastic frontier approach is model specification error, but data envelopment analysis is free from this case. So it is, but it is not free from limitations. Its main limitations is that the estimate is the best frontier based on the record of the output and input data for the few best performing. It does not consider the average, rather only few outliers can be a reference point or the frontier. Therefore, it is highly influenced by outliers. It is beyond normality, that means. So hence, the result is highly affected by measurement error. Even if it is free from model specification error, it is affected highly by measurement error. Still, there is possibility of high endogeneity in that case. Endogeneity in estimation of production function causes the parameters to be biased and inconsistent. So there must be some alternative mechanism to address such endogeneity issue so that our estimated parameters, coefficient parameters, could be consistent and unbiased. So moreover, it is difficult to conduct hypothesis testing with DA. Actually, nowadays, there are better developments that help the scholar to undertake hypothesis testing using DA, but the conventional approach in DA does not help hypothesis testing. The stochastic frontier, of course, I have comparatively stated with the DA. So the stochastic frontier or econometric estimation approach uses a specified production function. So it requires production function, whether it is, and it includes the noise, the statistical noise or stochastic component as error, which, as I have stated before, has been introduced in 1977 with independent two groups of scholars. So they have used cross-sectional data and criticized by others so that it does not allow us, the initial stochastic frontier approach does not allow us to check the long-run or structural patterns of the frontier over time. A single period data does not enable us to estimate individual efficiency scores, but only the average one. But nowadays, there are developments on this, and efficiency or inefficiency estimates for each of the units can be estimated. So the initial frontier, which is based on the cross-sectional data, does not allow us to compare the estimated results with the other analytical frameworks, such as the covariate component models. The fourth one has a limitation for the cross-sectional data approach. Cross-sectional data does not give information regarding the intertemporal nature of inefficiency. That is, whether inefficiency is time-varying or not. Based on this, there are developments, and the usual production functions for stochastic frontier approach could be Cobb-Douglas, translog, SACE, or whatever. Any of the methods can be used, but there should be, as far as we are concerned about stochastic frontier approach, there should be more specification of the production function or the production technology. That is mandatory. So let's come to the second part and comparison of the macro productivity level between Ethiopia and Indonesia, of course. So anyone can see from this slide, from this PPT, that the manufacturing sector, our focus is manufacturing, as we have outlined in the title. So the manufacturing sector labor productivity or partial productivity for the, specifically for the sector, the manufacturing sector, based on purchasing power parity. You see the blue line shows that the Indonesian labor productivity has grown significantly between 1965, around 1965, and to 2020, around 2020. So how it, even if there are ups and downs, but it could be considered as consistent growth over time, over this long time period, maybe more than 40 years, 60 years, more than 60 years time period. On the other hand, the Ethiopian case, the manufacturing sector productivity has shown increment around 1980s, early 1980s or 1980 exactly, but later after that, it has continuously declined. So later we'll see what could be the implication of this differential variation in labor productivity, particularly for the manufacturing sector, on other development outcomes. When we come to the growth rate, because previously I have stated that productivity can be level or at the growth rate. We have seen the level at this point, but the next is regarding the growth rates of productivity, labor productivity growth trends between Ethiopia, not only to the manufacturing, but in general, labor productivity growth for all sectors. Ethiopian case, the red line, it shows more fluctuations, more ups and downs. That means there is no stable policy-oriented growth. On the other hand, Indonesian labor productivity relative to the Ethiopian case, even if there are still fluctuations, ups and downs, but we can see that the growth rate, the labor productivity growth rate is stable on the Indonesian case as compared to the Ethiopian case. But on the average, the rate may be same, but the fluctuation matters in this case. Labor productivity level, instead of total labor productivity for all sectors, I mean, comparison at level, you can see that there is significant variation initially, 1980s, 1981, starting from 1981. The Ethiopian and Indonesian labor productivity, even from the starting, it is different. There is significant difference, variation. And the Indonesian labor productivity has grown as stable growth it has scored. Then the variation, the difference has been diverged. Instead of convergence, we can see the low-income country Ethiopia could not converge towards the relatively high-income country Indonesia. Now, in terms of total factor productivity, the Indonesian total factor productivity, of course, I could not find total factor productivity over time for Ethiopian case. But in Indonesian case, I have taken this data from Penn World database dataset. So Indonesian total factor productivity trend, very significant growth you can see from the diagram. Particularly between 1965, around 1965 and 2000, there is very high growth in total factor productivity. After that, the growth is more fluctuated, and still it could not reach the level which was in 2000. But the score of total factor productivity level over the before 2000 and 1965, around between this time period, then it has helped the country to achieve a very high per capita income. We'll see that difference later. So the difference in productivity level and growth might be the main cause for the divergence in per capita income, growth and level between these two countries. Look now, in terms of purchasing power parity comparison, real per capita income between Ethiopian case and Indonesian case, one can see from this diagram. Look now, the blue line, the Indonesian case, is steadily growing, but the Ethiopian case is slowly growing. Of course, it showed, particularly after 2000, it has shown growth, but it does not converge towards the per capita income level of the Indonesian case. Look now. The next is per capita income. Now we have seen the level, real per capita income in terms of purchasing power parity, in terms of USD. Now the growth rate in per capita income, per capita GDP, growth comparison, you can see the red line for consistency case is Ethiopian case and the blue is in the Indonesian case. Look now how, even if the growth rates are on average approximately similar, but the fluctuation is very ups and dips for the Ethiopian case, but in Indonesian case, except just before 2000, maybe 1998, 99, that time only is lowest that we can observe. Otherwise, per capita income has grown steadily, or it has followed the same rate, closely the same rate over 1981 to 2022. But the Ethiopian case, there were significant ups and downs. And as a result, even if in some periods, after maybe around 2005, after that, it shows higher growth rate, but still there are ups and downs. And still it could not make the average higher than the Indonesian case. So this may be explained by the variation in total factor productivity and labor productivity that we have discussed before. That is my suspicion. So what could be the possible reason for the difference in productivity levels and causes? Of course, productivity differentials we have observed, and income per capita differentials we have observed. So what could be the possible reason for the the productivity level and growth differentials? Let me hypothesize that is it human capital based on the endogenous growth theory, the endogenous growth models. So it could be, let me say, and let's see the human capital index for the two countries over long time periods. Look now, the Ethiopian and Indonesian human capital index, the variation. Initially, by 1960, around 1960, they have very close human capital index, which is close to less than 1.5 based on the index. After that, both countries, Indonesia and Ethiopia, have scored growing human capital, but the growth rate in human capital index, the growth rate in Indonesia is very steady and is very fast. As you can see from the graph, the blue line. Even if Ethiopian case, Ethiopian human capital has shown rapid growth after 2000, but it could not converge toward this from relative to our initial, it could not converge towards. So I can conclude that the variation in productivity may be significantly explained by the variation in human capital index, and therefore that in turn has caused the variation in per capita income. If there is any argument, of course, we can argue and we can go to further analysis. Now we have seen the macro level aspect, and let's start the micro level analysis based on the Ethiopian manufacturing firm data. The data and model specification part. Data from Ethiopian Central Statistical Agency has provided us the data over the period 1996 to 2015. For analysis purpose, we have grouped this data into 3 periods. The first period is 1996 to 2003, which Ethiopian economy growth was about 3.87, and it was fluctuating. For some of these years, there was negative growth, and for some of the years, positive higher growth relatively. So there were more fluctuations. This period is considered as more fluctuation. The second period, because we wanted to see the period dummy, we wanted to capture the policy orientations, the policy differences over that time period using the time dummy as policy dummy. So the second period is 2004 to 2010, which is considered as a very high economic growth period. On average, according to the official data and World Bank data, of course, 11.4% during this time period. The third time period that we have considered as policy orientation difference is 2011 to 2015, with similar high growth rate, but there was Ethiopian first growth and transformation period. Of course, the average growth rate is about 10%, more than 10%, which is closely similar to the second group of the period. So we have classified this basically for a reason, and model has been specified as follows. For productivity level estimation, we have used the Weldridge 2009 research result, finding specification. So, of course, as we have discussed before, the alternative productivity measurement errors or estimation errors, alternative methods, arise due to endogeneity in production function estimation. So Weldridge tried to resolve the endogeneity problem by estimating the productivity as a function of a certain beta and error time. So it has the Weldridge has used. So, and this dependent variable in the first equation, the dependent variable is real sales value for firms, manufacturing firms, and transformed into natural logarithm for the sake of growth, because we are dealing with panel data, unbalanced panel data. KIT is capital in natural logarithm of capital, real capital, and LIT is labor input. MIT in real raw material input, and the betas are as usual parameters to be estimated in the function. For total factor productivity growth, maximum likelihood estimation technique method is used. For determinants of total factor productivity, based on test Hausmann model specification test, we have used fixed effect estimator. based on the Hausmann model specification test result. So technical efficiency level, because we have to deal with productivity and technical efficiency, the model specifications may a little bit different, except the production function. So the four error component model, which was developed by Kumbhakar et al., is a distinguished professor and working on the same issue on productivity and efficiency for a long time period. And they have developed this 2014 step-by-step procedure. So in this case, gamma I represents firm specific heterogeneity, which was previously damped with the error term. VIT is the stochastic frontier, the stochastic error component. NI represents persistent or time invariant error component. I mean inefficiency component. UIT is the time varying or transient inefficiency component. So this step is a little bit a modification over the previous estimations of technical efficiency. For determinants of technical efficiency level, because as far as we have estimated efficiency and inefficiency, then what determines, the question immediately arises from our mind, is that what determines technical efficiency level? Whether it is time varying or time invariant, what is the determinant factor, the source? So for that, we have used Tobit model, as inefficiency or efficiency is truncated from below 0 and from above 1, because it is expressed in percentage. Therefore, 100% and 0%. So for that reason, for truncated cases, I mean censored cases, Tobit model better, not truncated, of course. For censored values, we have to use Tobit model. Shall I proceed to the major findings from this one? So two major parts are there, as we have discussed in the model specification: productivity level, growth and determinant, technical efficiency analysis with determinants. So two parts are there. Let's discuss over each of them separately, one by one. A comparative summary here based on different models or estimators, you can say. Total factor productivity level for ordinary least square, for fixed effects, for the Waldridge estimator, Robinson, another alternative, Oley and Peck's, Levinson, and Patrin. We have seen these alternatives. So among these alternatives, you can see the difference. The mean total factor productivity level ranges from 5.6, around 5.6 to more than 1,400. So these alternatives provide, on average, very significant different levels of total factor productivity, because they have used different approaches to avoid, to remove, or to tackle the endogeneity issues arising from production function endogeneity. Different sources of endogeneity are there. Therefore, recently, with justification, in this study, we have adopted the Waldridge approach, of course, as we have stated in the model specification part. But one can see that this much differences are observed over the different alternative estimators of total factor productivity level. And even the standard deviations are different. The minimum and the maximum levels are quite different among these ones. So there is still ongoing discussion and research on these various, because there is no conclusions that the best method is not so far among the scholars. Regarding this was the level. Regarding total factor productivity growth of manufacturing firms in Ethiopian case, summarized by the time dummies, the policy orientation periods, that means. So for the first period, 1996 to 2003, the average growth rate of total factor productivity was 3.6. On period 2, it was 4.7. And period 6, which showed the government's orientation in growth and transformation, first growth and transformation period, government's orientation to the manufacturing sector, the growth rate of the manufacturing total factor productivity was 6.5%. So how policy can matter in total factor productivity growth, we can observe on this issue. And on average, during the whole time period, total factor productivity has grown by 4.9% over that period at manufacturing firm level. So one can see that during the first period, with high fluctuation in economic growth period, that was the policy, initial policy orientation period, it was 3.6, but later it showed improvement over time. The next one is total factor productivity growth decomposition. What are the sources of this growth? Because usually the growth can be contributed in terms of technical progress, technical change, skill efficiency change, technical efficiency change. Of course, there is another one, allocative efficiency change, but here we have focused on the 3-1 in this study. Total factor productivity growth is decomposed into these components now, and technical progress was about 1% contribution, 1% growth, technical change. A scale efficiency change, it has shown negative contribution. Technical efficiency change, it has shown positive contribution to the growth of total factor productivity for the manufacturing firms in Ethiopian case. Do you see that scale where to intervene? Even for long-run economic growth and total factor productivity growth, technical change is the main driver, as economists have stressed. But now, in Ethiopian case, technical efficiency change, that is just improvement towards the frontier, has contributed higher than the technical progress. So the Ethiopian manufacturing total factor productivity growth is limited towards the potential only, the frontier. But if there were technical progress, more contribution from technical progress, then we should have considered that the frontier will shift outward, and hence there is possibility to expand further. So I think we can discuss this, we can understand this from. Graphically, we can see that technical progress, we have seen the scale, maybe if it is visible to all of you, the scale efficiency change is fluctuating ups and downs, showing more of negative from the starting, as considered from the starting, but TC, the technical change, is continuous. So it is not changing, it is growth. The good thing is technical efficiency change is growing steadily. But still, this means the economy, the manufacturing firms are getting closer. That does not mean they have reached the potential, but still they are running towards the potential. Then on average, this total factor productivity significantly affected. The shape and distribution of total factor productivity is significantly affected by the scale change, the scale efficiency change. So it is very influential part, that means. Regarding the determinants of total factor productivity growth, determinants of total factor productivity growth. Am I audible, audience? Any response from you?
Yes, sir. Audible. Yes, sir.
Okay, thank you. So regarding this of total factor productivity, we have selected different variables from literature, empirical findings, and we are presenting here only the significantly affecting variables only. The insignificant ones for the case of minimizing the summary presentation. So we have left out the insignificant variables. So labor productivity, one of the determinants is full-time employment of labor, taken as natural logarithm. So in order to interpret in terms of percentage, okay? So the coefficient is positive. It enhances total factor productivity. If we increase labor full-time employment, then we can increase productivity by about 1.4% if you increase by 1% full-time employment of labor. The other is size of the firm, because we have classified the size into three: large, small, medium into two, medium and large. Small ones were rejected. I mean, cancelled from this discussion because the focus of the data was large and medium. So the size large size has lower productivity growth as compared. This is contrary to our expectation, of course. Firms, as they get larger, their managerial inefficiency is more than the contribution of their capacity, their resource. So there is a negative relationship between total factor productivity growth and size of the firms. The other is ownership, public and private. So publicly owned enterprises, manufacturing enterprises, they are negatively contributing towards total factor productivity growth. Rest, we can see the periods, policy orientation periods. We have considered the first period as base, and between 2004 and 2010, there is positive relationship between total factor productivity and that period. And the other is 2011 and 2015. There is one more growth contributing. Capital intensity positively contributes to growth in total factor productivity. Wage per worker, average payments or average compensations to the workers as incentive. So if it increases by 1%, then productivity, total factor productivity will increase by 0.2%. Import status, importing firms as compared to not importing firms have positive economic growth contributing. Maybe they are importing imported capital goods for the production of manufacturing products. Let us proceed to the technical efficiency aspect. As far as we have discussed on total factor productivity level growth and determinants of that growth. Technical efficiency, as we have specified in the model, has persistent or time invariant component and transient time varying component. So the technical efficiency level in terms of transient or time invariant is about 64.2%. That means there is a possibility of about 35.8% improvement possibility towards the full potential. I mean, frontier. The full frontier is considered as the potential of production. In terms of persistent time invariant case, about 57.2% of efficiency level. Therefore, inefficiency level is about 42.8%. Therefore, there is possibility of improving technical efficiency by about 42.8%. On overall technical efficiency is not the sum of this, rather the product of this technical efficiency. The persistent times the transient will give you the overall technical efficiency. Then the technical efficiency is about 37% totally. Therefore, there is a good deal of possibility to improve. Now the status is very low, but as far as we are focusing on improvement, there is a good deal to improve towards the frontier. This about 37 or 36.7% of overall technical efficiency level means we can improve production by 63.3% without any additional cost, input cost, just by improving the know-how, the existing know-how. This is a good potential for Ethiopia to improve its production. But the cost is there should be a committed, policy-oriented effort to make these improvements. Otherwise, using the existing inputs and existing know-how, technical know-how, we can improve. Without technical change, that means we can improve this production technically. We have seen these efficiency components levels graphically over time, but they are steady over time. There is no such significant improvement over the time period considered for this study. Regarding determinants of technical efficiency, in the first case, transit technical efficiency. Transit means time varying. So these determinants, we can see that capital intensity affects negatively the transit technical efficiency, and market power concentration ratio, which is measured by HHI-JI, is also negative. So the market power, if it increases by 1%, as measured by proxied by this, it reduces transit technical efficiency by about 0.3%. And the rest variables, the time period variables, the size variable. Now, previously we have seen in terms of productivity growth, large size was negatively related with productivity growth, but in terms of time varying efficiency, so it is positively related. On the other hand, export status, import status, these have both export and import status have positive relationship with transit technical efficiency. The regarding determinants of persistent one, time invariant one, technical efficiency. So these determinants may have different effects. For example, large size firms are better in terms of time varying efficiency, but on time invariant efficiency, they are negatively related. So there should be compromising or addressing the problem related to why it is negatively related with persistent one. Rather, it is enhancing the time varying efficiency, but it is drawing back the time invariant one. So there must be some reconciliation between the two for appropriate policy intervention. Capital intensity, it has in both of the transit and the persistent case, it has negative effect. Import and export status, they have positive effect on transit or time varying efficiency level, but they are negatively related with persistent ones. So there must be some structural problem related to this one. Because persistent technical efficiency means structural. Persistent technical inefficiency is due to structural problems. So there are some structural problems which make import and export, maybe this may be related to the customs, related to the import-export, related to the rationing of the foreign currency, or some reason around which may cause the relationship between export status and import status to be negatively related, and also size. Let me come to the conclusion part. On average, particularly from the microeconomic aspects, the microanalysis aspect, on average, the growth rate of total factor productivity is 4.87% over that time period. And it showed improvement over the different time periods. It has shown growth. So policy interventions, policy orientation time periods are associated with improvements in total factor productivity growth, which supports that the policy orientation towards manufacturing during the first time period, I mean the first growth and transformation period in Ethiopia, played an important role. This growth rate is contributed by, as we have discussed, technical efficiency, technical progress, 1%. Scale efficiency change is negative 0.14%. And technical efficiency change, 4.01%. Thus, more than 82.34% of total factor productivity growth is contributed by just technical efficiency improvement. The others, technical progress particularly, is not playing a role, and scale efficiency change particularly is negatively decelerating, that means decelerating the growth rate. However, the shape and distribution of, as we have seen in the graphs previously plotted, distribution of total factor productivity is significantly determined by the scale efficiency change. Total factor productivity growth accelerates or enhances our labor growth, labor employment growth, policy orientation, capital intensity, and labor quality importing. So the policy implications of these firm level findings are regulation towards efficient utilization of firm size, because the firm size, larger firms are negatively related with persistent efficiency, and also productivity growth is negatively affected by large firms. So therefore, maybe managerial issues are there, because as firms increase their size, managerial inefficiency may outweigh. For this, there should be important intervention for this improvement. And the negative effect of scale change should be also taken into account in case of policies. I know that the Ethiopian government is trying to improve the manufacturing sector, and they are now moving on this aspect, but they should take specific and planned measures. The second possible policy implication for the findings is strategic interventions, improve efficiency gains from international competitive environment. Because importing and exporting have negative impact on persistent efficiency level. Therefore, there must be, from competitiveness point of view, there is a need for intervention. Importing new technology embodied capital, because as other studies showed, the current capital installed in Ethiopia is old, and even there is underutilization of the capacity of the old one. So there is a need for new capital, new technology embodied capital importing or maybe developing here, if possible, to exploit the advantages of unlimited global market now. Otherwise, it could be difficult with older technology installed. It could be difficult to be competitive enough, and hence the global market may not be supporting us. Capital intensity and growth in labor inputs, improved scale change, implying the growth in capital should be accompanied with the labor input. Because capital intensity means the capital labor composition is now, if it increases, capital intensity increases, persistent efficiency is declining, and therefore we have to make certain decisions in the complementary nature of labor input and capital input, so that total factor productivity growth increases through improvement in scale efficiency and other ones. This was on the total factor productivity growth aspect for policy implications. From technical efficiency aspect, the average estimated time varying time invariant and overall technical efficiency were this much, as we have discussed before. A potential to rise the real value added by about 63.3% for given set of inputs and using the prevailing technology is possible, as far as there is managerial improvement in the manufacturing sector. So this tackles to the factors that cause persistent inefficiency. There is a need for tackling inefficiency, particularly related to firm size, causing coordination problems. Firm size may be, when firm size increases, technical efficiency decreases, particularly persistent one. Therefore, this may be a problem caused by coordination failure. Therefore, there should be intervention towards addressing such coordination failures, managerial issues. Capital intensity, perhaps addition of old capital may have caused the size may be stock of older capital. Of course, other studies have confirmed this too. So there is a need for advancing, renovating, if possible, renovating of capitals. If new capital addition is not possible, renovation can improve, can address the problem. So participation in import-export, perhaps related to customs and access to foreign currency, there should be improvement in that case. Thank you so much. This was all my presentation. Maybe if there are doubts for clarification or maybe additional elaborations can be allowed. Thank you so much.
Okay, thank you for your presentation. For our participant, if you have any questions for the speaker, please add them to the chat or you can raise your hand. Okay, first question, we have question from Mr. Perede mengisti alemo. Yeah, the question is why use the alternative tool to examine the level of productivity? Thank you. Russia?
Okay.
Yeah.
Shall I respond to the first question? In text, I could see that one question
Yeah.
is
Yeah, you can
relevant.
answer, sir.
Yes. So, Sarada has asked us why use the alternative tools to explain the level of productivity. Yes, of course, we have chosen one for a reason, but it is good in my view that we have to compare methodologies because there are alternative methodologies and research studies so far, empirical studies have used different among these alternatives, and we have reviewed different literature based on different estimation techniques, which use different. Therefore, methodological research, just even if this is empirical research, so it is good in my view to show to the readers, to my readers, that the alternative methods have differences to this extent on the average total factor productivity level estimation. That is the reason that I have presented the alternatives, because I consider this is a discussion, is an academic discussion. So I considered. Otherwise, I have published one paper on separately on comparison of recent developments on productivity estimation.
Yeah, thank
Thank you
you.
further for your question.
Okay, thank you for answering. And we are still waiting for question from our participant. I think we don't have no more question again, sure, from our participant.
Okay.
Before I close this event, for all participants, please open your camera. I will take a picture on the count of three. Okay, 1, 2, 3. Okay, another one. 1, 2, 3. Thank you for your keen cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Mr. Yismaw for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have a collaboration in the future with Debre Tabor University, Ethiopia. The visiting lecture for today, and here we have to see you soon. Thank you and have a nice day. Thank you for Miss Dr. Yismaw.
Thank you so much.
Yeah,
Thank
have
you.
a nice day and
See
goodbye.
you. I hope we'll have coordinations and collaborations for research conference
Yeah,
too.
I will. Yeah, thank you and
Thank
goodbye.
you